Hey there! In this video, we're going to go over the very important concept of when left and right Riemann sums are over or underestimates, as well as when trapezoidal approximations, trapezoidal sums, are over or underestimates. So let's check it out very simply. For all of this, just draw a picture. So if you've got a curve f of x, right? So let's say that f of x is just some curve going up like this, right? Or going up like this. Either way, if you've got f of x, it's increasing in both of these intervals. So if you were to do a left-hand approximation, notice that every rectangle would fall below the curve, no matter which curve we use here. And so a left-hand approximation is going to be an underestimate when f is increasing. That's it. So f is increasing, then a left hand is an over approximate. So let's do this. Let's make out a table. I'll do left. I'll do right, and I'm going to do signs of f prime here. That's all we're going to do. So we'll do where f prime is greater than 0. That'd be f is increasing and f prime is less than 0. Now you could memorize this, or you could just draw it out every time. So a left sum when f prime is greater than 0, when the curve's increasing, is an under approximate. And a right Riemann sum would therefore be an over. And let's see why it's an over. If I were to draw in rectangles on either of these, it would go over the curve every single time. And that doesn't matter if you're concave up or concave down. The right hand will be an over. Draw out the picture. So if they tell you a curve's decreasing, for instance, I'll do this over here, just kind of haphazardly. Decreasing could look like that or like that. Well, now your left-hand approximations are going to be over approximations. Don't memorize it, just draw it out. So if a problem says, hey, the curve's decreasing everywhere, draw a decreasing curve, draw on a left-hand rectangle and say, oh, it goes over it. So this would be where f prime is less than 0, and a left Riemann sum would therefore be an over approximation, and a right hand by default would be an under. And you can see the right hand here, draw on a right hand one, and then stretch it out that way. And that goes under the curve. This one too, under the curve. That's it. Draw the curves out and you'll know it. That table might help you, but don't memorize it. See it, understand it. Okay, trapezoidal approximations are a little bit different. It actually is not about whether the curve's increasing or decreasing. So if I draw f of x, and I draw that like this versus g of x, and I'll draw g of x concave down. Let's make a trapezoid and see which one's an over and which one's an under approximation. So if I stretch out a trapezoid something like this, and I draw on that trapezoid, what forms the trapezoid is a secant line, essentially, of f of x. And so when we're concave up, the tangent lines are below, but the secant lines are above. And again, just like with the Riemann sums, draw it out. So here, we've got a trapezoidal approximation, and I'll just write it like this. When f double prime is greater than 0, when the curve is concave or up, we know that we're going to have an over approximation. That is for a trapezoid. When it's concave down, f double prime we know is less than 0. Draw it out. You don't have to memorize it, for the love of everything that is good in this world. This right here is a secant line, and it falls below the curve when it is concave down. And so that would be an under approximation. That's it. So the moral of the story here is don't memorize these things. Draw it out. Understand that because trapezoids utilize secant lines here and here, the approximation depends on the concavity of the curve. And with Riemann sums, understand that it's whether the curve is increasing or decreasing. So whether f prime's positive or negative. Don't memorize the chart. Draw out the curve and a rectangle to see whether it falls under or over. That's it, y'all. I will see you in the exercises. Peace.